go over this and see how you did. So vertex form. First, I want to know how my vertex got to where it currently is. Because normally, remember the parent function, its vertex is at 0, 0. So the vertex moved here by going right 1 and down 4. So right 1, down 4. So to make the graph go right 1, in parentheses, I would need x minus 1. To make it go down 4 in the back, I would need minus 4. So at the vertex, after we move right 1, it takes going up 1 to hit the graph. So that means my A is a 1. And that's vertex form. That was the new stuff from yesterday. Okay, now let's go over here and see how you did with the old stuff. So the vertex is this guy down here. It's the lowest point of this graph. And to get there, you go right 1 and down 4. So that's the point 1, negative 4. Because it's the lowest point, it's a minimum. How low is it? It's negative 4 low. And that's because that's the y-coordinate of the vertex. Your axis of symmetry is the vertical line that splits that parabola in half. Remember, all vertical lines are vuxes. So it's going to be x equals, and your x is a 1 everywhere here. Remember, it's always going to be the same as the x value to your vertex. Zeros. This is where the graph touches the x-axis, called x-intercepts, zeros, roots, and solutions. It touches at negative 1, and it touches at 3. Okay, a y-intercept is where the graph touches the y-axis. And the graph is touching the y-axis right there. And that is the ordered pair 0, negative 3. Remember, y-intercepts always have a 0 in the x spot. Remember when we were doing it on the graphing calculator and we went to the table, we were always looking for 0 in the x spot for y-intercepts. Okay, this graph goes forever to the left, forever to the right, so the domain is all real numbers. And then the lowest y value I have is down here at negative 4. So the y starts out equaling a negative 4. And then when the graph goes up, 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 the y's get greater. Okay, hopefully you did pretty well with that. All right, today we are going to talk about something called factored form. Okay, so first I'm just going to flip this over and remind you of something we did before spring break and before all of this craziness happened. So we had problems that we had factored, and let's just say we factored it to look something like this. And I was trying to solve it. So in these problems, I was setting everything equal to 0. So I was setting this equal to 0. So then I took my first factor, I set it equal to 0, and then I took my second factor and I set it equal to 0. And then I solved those two equations. I don't know, when we were doing this before spring break, I felt like most of you understood. Do you feel like you kind of remember this? So if I was to solve this equation, I'd add 2 to both sides and I'd get x equals 2. And if I was to solve this equation, I would subtract 5 from each side and I'd get x equals negative 5. And those would be my solutions, my roots, my x-intercepts, my zeros. So we were finding those answers all kinds of ways. We had problems where we factored, we had the square root method, we did quadratic formula. So I wanted to show you the factored method because today we're going to write our equations in factored form, and this is what factored form looks like. Okay, visually, I wanted to remind you what that looks like on a graph. So if I was to graph x minus 2 and x plus 5, let's see where this graph touches the x-axis. It touches at 2 and it touches at negative 5. And to be certain, remember we can go to the table and I know it touches at negative 5 because there's a 0 in the y column. And I know it touches at 2 because there's a 0 in the y column. So, yep, negative 5 is an answer and 2 is an answer. And that's another reason why those are called zeros, because there's a 0 for the y right there and there's a 0 for the y right there. So negative 5 and 2 are the answers, which I knew when I solved it. Okay, so what we're going to do today is we're going to go backwards. You're going to see the picture and then write the factored form. So if it touches at a positive 2, you're going to write x minus 2. If it touches at a negative 5, you're going to write x plus 5. So the factors are always going to be the opposite. Okay? So I want to show you what I mean. So I'm going to go to these two problems, and I'm going to do these in factored form. Okay, so I'm going to write factored form. And factored form is going to have two sets of parentheses for the two locations that the graph touches the x-axis. So if it touches the x-axis at negative 4, the factor is going to be x plus 4. If it touches at 0, it's going to be x minus 0 or x plus 0. The 0 is kind of a tricky one because it doesn't matter if it's x plus 0 or x minus 0. And then I need my a. My a is going to be the number in the very front. So I go to the vertex. It's right 1, down 1. So my a is a negative 1. Just like my a was a negative 1 when I wrote it in vertex form. Okay, now if that didn't make sense to you, what happens if you set this x plus 4 right here equal to 0? If you were to set x plus 4 equal to 0 and solve that equation, what would you get? You would subtract the 4 from both sides, and 0 minus 4 is negative 4. Well, isn't that where it's touching? Is that negative 4? So in order to do factored form, you look to see where the graph touches the x-axis, and then the factors will use the opposite signs. So let's look at this one. If I was to write this in factored form, I'm going to have two sets of parentheses for where the graph touches the x-axis. Well, that is if it touches twice. So if the graph didn't touch the x-axis twice, we wouldn't have two sets of parentheses. Okay, so it's touching at negative 1. So if it's touching at negative 1, the factor is going to be x plus 1. And it's touching at positive 3, and if it's touching at positive 3, the factor is going to be x minus 3. And then the guy in the very front is going to be my a. So when I go to the vertex, after I go right 1, it takes going up 1 to hit the graph, so my a is a 1. Just like it was when I did vertex form. Okay, let's look at a couple others real quick. So these were problems that I was working on yesterday as well. Okay, so I'm just going to practice my factored form for this problem. So factored form. All right, so looking at this picture, how many times does the graph touch the x-axis? Twice. 1, 2. So I'm going to have two sets of parentheses. And so it's touching at a positive 2. So what do you think the factor would be? X minus 2. And it's touching at a positive 4. So what do you think the factor would be? X minus 4. Okay, and then to find your a, after I go right 1, I have to go up 2. So my a is a 2. What do you think of factored form? Do you understand? And the reason it's the opposite is because if you were to set x minus 2 equal to 0 and solve that equation, you'd get a positive 2. And if you were to set x minus 4 equal to 0 and solve that equation, you'd add 4 and you'd get a positive 4. So that's why they're always going to be opposite signs. Okay, let's look at this one. So factored form. So it's touching the x-axis twice. So I'm going to have two sets of parentheses. So when it touches at 0, it could be x minus 0 or x plus 0. And it's also touching at 4. So what do you think it's going to be? X minus 4. Now let's look at our a. Go to the vertex. After you go right 1, you have to do what? You have to go down 1 to hit the graph. So our a is a -1, and that's factored form, and we're done. So today I'm basically trying to teach you factored form. So factored form has to do with where your graph is touching the x-axis. Okay, just like I showed you on the graphing calculator. So just to go back to that, this is what factored form looks like. And so when it is a -2, do you see how it's touching at a +2? And when it's a +5, see how it's touching at a -5? So this is called factored form and has everything to do with where the graph touches the x-axis. Okay, so what I want you to do for me is this third problem on this paper here. So I'm going to have you practice vertex form again. And I'm going to have you practice the new thing, factored form. So vertex form, just to remind you, that's how the vertex gets to its new location. So like this one went right 1 and down 4. So I had x minus 1 in parentheses for the right one, and I had -4 in the back for the down 4. And then your a value, of course, we had to go right 1 and up 1 to hit the graph, so that's why the a was 1. And then factored form is about where the graph is touching the x-axis. So if it touches at -1, it's going to say x plus 1 for the factor. And if it is +3, it's going to say x minus 3 for the factor. And then, of course, the a you get for this guy will be the a that you get for this guy. So looking at this picture, I want you to figure out vertex form, factored form, and then I also want you to review the old stuff too, because I want to make sure that you don't forget how to do this stuff as well. Okay, so this is all linked on your Canvas calendar. So if you're able to print, then you can do that. And if not, you'll just have to write your answers on a separate piece of paper. And then I want you to take a picture of them and post to Canvas. And that's all for today.